members of LoRa Alliance, have deployed this technology to provide planet-wide coverage. Effectively, what we're building is the digital nervous system of the planet, sensing what's happening, turning it into digital data, and transmitting that to the brain.
Welcome to We Talk IoT, where we explore the ideas and impact behind AI-driven tech of the future and how data creates real business opportunities. To stay ahead of the innovation curve, subscribe to our newsletters on the FNet Silica website. I am your host, Ruth Haydock. From tracking endangered rhinos across the African savanna to optimizing operations at the world's busiest airports, one IoT protocol has become the backbone of industrial connectivity. Welcome to We Talk IoT. Today we are exploring the LoRaWAN technology that powers 125 million devices worldwide. I am joined by Alper Yegin, CEO of the LoRa Alliance, the non-profit consortium driving this expansion. With 350 members, including Amazon, Comcast, Verizon, and Airbus, the Alliance has spent the past decade building a successful long-range, low-power network standard. Welcome, Alper. I'm really glad to have you on the show. How are you today?
Thank you very much, Ruth. It's a pleasure to be here. Doing well. Thank you.
As I understand, you are celebrating your 10th anniversary this year and 125 million connected devices. That's incredible.
This whole journey started back in 2015, aiming to crack a problem that's been lingering in the industry: how to provide a wireless communication technology that can operate over long distances, like miles and kilometers of range, while consuming as little power as a garage door opener. And doing so using unlicensed band, so anyone can use this technology, and making it very cost efficient, so it can be highly accessible. So that's what we were set to do 10 years ago, and that's what we've been doing all along, and that's where we are.
Terrific. And what makes LoRaWAN the right choice for enterprise IoT? You have mentioned it's open source, it's low range, it is an unregistered frequency.
Right. Yeah. So, the LoRaWAN technology, actually, it does cater to all 7 verticals of the IoT, like smart cities, smart buildings, smart home, smart agriculture, industry, utilities, and logistics, all the way from serving public operators who are building nationwide networks or even continent-wide networks, like the EchoStar Mobile providing pan-European coverage using their geosatellite, all the way from there down to people building IoT networks in their enterprises. So we have a very wide range of applicability for our technology. Now, if we're talking about why this technology is an enabler for the enterprise IoT, which could obviously be spanning facility management, smart factories, smart agriculture, things like that. The benefits of LoRaWAN is, the technology being highly accessible. Now, for a wireless technology to be accessible, first of all, it needs to be low cost. In terms of the cost of building LoRaWAN networks, this being a wireless technology, one needs to have base stations or access points, or what we call in our terminology LoRaWAN gateways. The price point for this type of equipment is converging towards the price of Wi-Fi access points, both indoor and outdoor. So this is just to tell you and audience that how low cost building these networks is. And secondly, just like again with Wi-Fi, we're using an unlicensed band, meaning that in order for an enterprise to build an IoT network of its own, a private one, they don't need to get an expensive and limited license from the government, like what GSM and its derivatives require.
Okay.
Just like Wi-Fi, anyone can go buy a LoRaWAN gateway and plug it into their local area network, and then they built their IoT network based on LoRaWAN. And it's long range. Now, the corollary to being long range is the ability to penetrate through the walls and other obstacles. When people deploy LoRaWAN in open space, where the extreme cases, there's a perfect line of sight, the range of communication between an IoT sensor and the LoRaWAN gateway can be as large as 600 kilometers.
Wow.
Yeah, it's really mind-boggling, right? That's
Mm-hmm.
exactly why we have LoRa Alliance member companies placing LoRaWAN gateways on the low Earth orbiting satellites to pick
Mm-hmm.
data from sensors on the ground, such as Plan S and Lacuna Space, two commercial LEO operators, members of LoRa Alliance,
Mm-hmm.
have deployed this technology to provide planet-wide coverage. Obviously, coming to an enterprise, they don't typically need a 600-kilometer range, right? What they need is a campus-wide coverage or building-wide coverage. When you constrain the signal inside buildings, it uses its power, or more technically, its sensitivity, to penetrate through the walls. That's why, with very few indoor LoRaWAN gateways, one is able to cover a whole building, a whole campus. In a typical building, a LoRaWAN gateway placed on a floor provides coverage for 2 floors up and 2 floors down,
Okay.
and penetrating through multiple walls on the same floor. And again, typically, not only an indoor coverage is provided, but the signals go outside, and they also provide outside coverage as well.
Mm-hmm.
And coming back to your question, enterprise, they tend to prefer building and owning and operating their own private network, much like they do it with Wi-Fi. So they own the gateways, and then they decide what devices connect and what devices cannot. Same thing is applicable to LoRaWAN as well. They easily and at a very low cost build a campus-wide network, and then they provision devices of their own. And even though the signals can physically go outside, they don't let others eavesdrop or
Mm-hmm.
connect, because we have
Yeah.
full cryptographic security protecting these private networks from any unauthorized access.
And you mentioned when we talked before that you are the most deployed LP1 outside of China.
Mhm.
Huh. How do you compare with NB-IoT or MyOT?
When LoRaWAN started back in 2015, there was already a couple technologies in the so-called LPWAN area. LPWAN stands for low power wide area networking. The
Mm.
mix of providing long range while consuming little power. That's the category that we've been operating. So before LoRaWAN came along, there was already a few other technologies, most notably Sigfox. Then
Mhm.
after 2015, other technologies started emerging, seeing that there's a real market for LPWAN and seeing that LoRaWAN is gaining so much momentum, the market opportunity became clear to the other players as well. And that's when the competing technologies started emerging. And within this 10 years of time, LoRaWAN clearly took the pole position. So Sigfox, having had a 2 year head start, meaning
Mhm.
that they had started deploying 2 years before LoRaWAN did, they had a pretty good nationwide networks deployed in several countries. But given that technology has been a closed technology, not an open one, like having an alliance behind it,
Mhm.
the technology was owned and operated by a single company. That prevented it from scaling. So today there are Sigfox networks, but they have lost their momentum, and they are far behind of LoRaWAN.
Mhm.
And then 3GPP, obviously, typically 3GPP and the GSM industry, they are pretty reactive. Unless they see a huge opportunity, they don't mobilize until
Okay.
they see someone else is capitalizing on such opportunities.
Mhm.
Well, that was the case, for example, back in the days with WiMAX and LTE.
Mhm.
So those were two competing 4G technologies. WiMAX coming from outside GSM,
Mm.
and seeing that it was already gaining momentum, then the 3GPP reacted by building LTE, a competing technology. Those two technologies, one from GSM, one from WiMAX Forum, they were on a head-on collision course, and for that,
Mhm.
one had to win. There was no room for two equivalent technologies, and that's what happened with the LTE winning. Now,
Okay.
the similar story started unfolding with Narrowband IoT, but Narrowband IoT and LoRaWAN are not really on a head-on collision, because the functionality wise, they are not equivalent. Narrowband
Okay.
IoT is using a license band.
Mhm.
It's only available to operators, so you or your colleagues or anyone else cannot deploy it freely on their own, like one can do with Wi-Fi or LoRaWAN.
Okay.
And it is nowhere near as low power as LoRaWAN is. because LoRaWAN was built from scratch for efficiency, whereas Narrowband IoT is a retrofitted version of 4G LTE. So it can
Okay.
never be as simplified, as low cost, and as low power as LoRaWAN is. And hence, even though Narrowband IoT did have a spike in the past, it started losing steam both internationally and even in China. Internationally, operators like Docomo and AT&T, they pulled the plug on Narrowband IoT. Those services are discontinued. So internationally, momentum has been significantly down. Now, I do mention China because China has a special position here. The government has endorsed Narrowband IoT back in 2019 as the wide area IoT network. That's
Okay.
why a majority, like 90% of Narrowband IoT connections are in China. And even that has been slowing down, basically yielding the floor to Cat1 Biz, another technology which is more power hungry and also costlier than Narrowband IoT. So
Mm.
the momentum has been slowing down in China, and it's been pretty much, I would say, fizzled away internationally. As such, discounting the number of devices in China, in the international market, LoRaWAN has more devices connected and also much faster growth than Narrowband IoT.
Mhm.
In China, again, the growth of LoRaWAN is higher than Narrowband IoT, but the
Mhm.
sheer numbers of their deployments is still more than LoRaWAN in China.
Mm. It's interesting. I imagine being a IT decision maker or business decision maker, it's always really hard to keep track of all the different standards and all the different technologies that at the beginning of the innovation phase are all competing against each other until one steps ahead or makes a real business case or real interesting use cases where you can then translate your own needs to what solution fits best.
Right, exactly. And then there are a few other technologies as well that has been around in the past. I mean, since the beginning, like Wi-Sun has been around, which is mostly used for electric metering and street lighting.
Mhm.
So compared to LoRaWAN, I mean, LoRaWAN is serving basically all verticals. It's not just one or two use cases. Practically any use case of IoT can be served by LoRaWAN.
Mhm.
And two exceptions being, one is like if a use case requires transmitting megabytes and gigabytes of data per sensor per day, that is not for LoRaWAN. Because
Mm.
we're using unlicensed band and long range, we cannot transmit such big data. So if we're talking about connecting a camera, it's not for LoRaWAN. Or
Okay.
connecting a car that tends to transmit megabytes and gigabytes of data, that's not for LoRaWAN. And the
Mhm.
other one is if the use case requires a real-time communication, meaning that guaranteed delivery under milliseconds, at the milliseconds granularity. Say
Mhm.
you're controlling a robotic surgical arm, Da Vinci arm, right? That you press a
Okay.
button on a continent and the patient is operated in
Mm.
an operating room in another continent. Then
Mhm.
you need guaranteed latency. Then definitely LoRaWAN is not meant for that. Or
Okay.
if you're controlling a drone that you press a button and you want that drone to make a turn
Mm.
in split second, guaranteed delivery. For those kind of things, one needs a licensed band technology like Narrowband IoT or LTM.
Mhm.
And then there were even other technologies that popped up and disappeared, like Altres, another technology that came into LPWAN, but we don't hear about it anymore. And then there's WirePass, and then the latest entry is MIoT. Now, when we look at MIoT, the kind of features the MIoT brings to the table is basically superseded by anything we already have with LoRaWAN, all the way from being low power, long range, providing high density networks. In terms of the density, we see the highest density of networks when we place base stations high up, as high as, like I said before, 600 kilometers. When
Mhm.
you mount a base station that high, the
Mhm.
coverage it provides go all the way up to 3,000 kilometers. Then
Wow.
millions of devices fall under that coverage
Yeah.
looking at the sky. That is the
Mhm.
kind of density we're talking about. And for that density, we already have a modulation technique supported by a LoRaWAN called LRFHSS for that
Mhm.
level of scalability. We only face that kind of challenge for the satellite networks. This type of density is not required on the ground. And for any density one has on the ground, LoRa modulation with the LoRaWAN is already sufficient, and that's what our utility operators are already proving in the field.
Yeah, we have so much to unpack. Maybe we should dive into use cases now and make it more tangible. You've mentioned all the verticals. You mentioned smart cities, agriculture, utilities. Tell us about your most transformative use cases you have seen in the past. What has really stood out for you?
Yeah, so we have so many use cases every day. We are discovering one. That's the beauty of this technology being highly accessible, from all regions of the world and all walks of life, from students doing projects to multinationals. What I find interesting, and I think people would find interesting, is so one example is in the smart buildings or facility management.
Mm-hmm.
Given its low cost, low power, high penetration nature, we see tremendous amount of momentum. For example, in North America, more than half of the Starbucks stores have
Mm-hmm.
deployed LoRaWAN for cold chain monitoring. So when people are picking their favorite drink from Starbucks, there's a pretty good chance they're already inside the LoRaWAN network. But
Okay.
that's a private network built by Starbucks for monitoring the temperature sensors they have in more than 10 places in a typical Starbucks store. And the motivation behind that was to save time, because up until they connected their sensors wirelessly, one had to
Mm-hmm.
spend 25 minutes per store per day to check on those temperature sensors.
Okay.
Now, those 25 minutes are going towards making their customers happier, and that's a saving. Now, jumping from a Starbucks coffee shop in United States to, say, Africa, right? So I'm going to take you through a little tour here.
Yeah, that's nice.
Yeah, we've got more than 35 national parks, wildlife parks across 10 nations have deployed LoRaWAN for helping basically the planet. What they do is they track endangered species like black rhinos and elephants that
Mm-hmm.
has LoRaWAN connected trackers. And through that, they can monitor their movement to check up on their health and also behavior, which can reveal if they are getting sick or if they're under attack or being chased by poachers.
Mm-hmm.
So that has significantly reduced the poaching activity in those parks. On top of that, they also track the ranger vehicles and the rangers themselves to make sure they are patrolling the region, which also further reduces the poaching activity. And
Mm-hmm.
even the ranger dogs do have trackers, and there are
Okay.
video clips of IoT dashboards showing how the poachers get busted by the dogs chasing them. You can see them
Okay.
all on IoT dashboards. And tracking the speed of the tourist vehicle to prevent overpopulation and overspeeding, things like that.
Mm-hmm.
Another truly life-changing use case is the panic buttons.
Mm-hmm.
So we have a member company in LoRa Alliance. They built a panic button solution using LoRaWAN. With panic button, what one needs is long battery lifetime. So it's not that when you need it. And also the ability for the signals to go through the walls. So every corner of a facility and outside can be covered. So
Mm-hmm.
that member has deployed more than 700,000 panic buttons across 15,000 locations in North America again. And they are mostly used at schools, hospitals, and hotels.
Okay.
And there were even incidents where these panic buttons were engaged, which dispatched the law enforcement to arrive at the scene under 2 minutes
Oh, wow.
to save lives. Literally, lives
Mm-hmm.
have been saved by the LoRaWAN connected panic buttons. So whether it's like saving people or planet, and obviously all the obvious business cases like operating oil refineries, steel manufacturing sites, connecting more than 5 million water meters across France using a nationwide network by Orange. Those are always the typical cases that everyone has
Mm.
heard a lot. What is really special with our case is that we have this happening already unfolding. None of these are theory, these are real hard numbers in the field and touching lives all across the globe.
That's incredible. I find it really inspiring how tech can also help solve the critical problems that we are facing as humanity and the planet in general. And especially the anti-poaching and environmental use cases I find always very interesting. We had a guest on the show. He was building with chemical sensors, basically not an Internet of Things, but an Internet of Trees. And the sensors help prevent wildfires before they start.
Probably the same could be, right? Dryad.
Yes, thank you. We had the CEO of Dryad on the show last year, and it was incredible what they were doing with the chemical sensors and
Right.
how much area of a forest they can cover just by these small, tiny things they can put on trees.
Exactly. So, as you must have already covered in that show, just briefly, what is really special with their solution is it detects the ignition. Unlike the other
Yeah,
solutions that requires the fire to
already
grow to a
have
point
been.
that there's a
Yeah.
visible smoke or
Mm,
fire that can be detected by cameras or satellites and all that.
mm,
This does catch the fire at the ignition within the first 2 minutes. And now, once it catches, what is it going to do? It has to signal that. Now that's where LoRaWAN comes into the picture. Long range nature helps these sensors be embedded in the forest and the
mm,
data being picked by long range communication, whether it's done terrestrially or also they do have direct to satellite communication as well using LoRaWAN again. So obviously, I mean, LoRaWAN is part of their solution, but it's an critical part of it by providing the long range because those
mhm.
sensors have to communicate with receivers that are far outside the forest.
Yes.
And obviously, I mean, the nature is acting up, right? I mean, there's all these natural disasters are
Mm,
increasing in number and intensity, fire, flood, earthquakes, and hurricanes, and all that. Yeah, LoRaWAN is doing its part already on these fronts. And again, it's the same thing, being long range, low power, low cost. That's the enabler. That's why you
mhm,
don't see a Zigbee or Bluetooth or Nirvana IoT based solution in any one of these cases. Because where these things are happening, there's no public operator or there's no way you can build such a wide array network using such a short range radio like Wi-Fi, Zigbee, Z-Wave, Bluetooth. So that's where
mhm.
we stand out, and the market or the people is noticing that already, obviously, and leveraging it in many ways that is helping people, planet, and obviously businesses as well. So,
What would you think are the biggest integration challenges businesses face?
well, I mean, the IoT itself is really challenging. It's been around for almost 4 decades.
Mm,
Obviously, we are operating inside the IoT realm, and we are affected by that as well. IoT at first appears like a huge opportunity, like billions of devices, right? But when someone starts looking little closer, they realize that billion device market is so fragmented across regions, across use cases, and even adjacent use cases end up requiring very distinct efforts. So, once you look into IoT, you go like, okay, tracking looks interesting. Then you look into tracking. Oh, there is people tracking, equipment tracking, other asset tracking. Then you go like, okay, how about animal tracking? Then there's a cat tracking, dog tracking, cow tracking. These are also distinct. And then all of a sudden, that billion unit market becomes like say, a million unit market.
mm,
That's where the challenge begins. The second challenge is for cracking that market, you need to integrate several things like a chip, a device, a network, an application, and then you need to have a support, you need to have a sales channel, marketing, etc. And that's another challenge. And that's why cracking all these markets have been taking so long overall in IoT. And that's why things don't happen overnight with LoRaWAN either. But I can tell you this, I mean, the IoT market has been slow progressing.
mm,
LoRaWAN has been accelerating that. So when we reach 125 million devices with 20% growth year over year, we are far ahead of typical IoT growth for any other IoT technology. So we're pushing the envelope here, which is not only accelerating the market for LoRaWAN using IoT cases, but also the rest is also coming along because a
mm,
device built for LoRaWAN may be used for other technologies as well. So we're basically rising the whole market for everyone. But yeah, it is the biggest challenge is the integration, integrating all these components. And also
mhm.
the market is still somewhat in an education mode for the IoT. The prospects understanding their needs, the prospects understanding the possibilities, what can be done, what cannot be done. And then the IoT companies understanding the verticals. So there's this two-way walk towards each other.
Yeah.
And it's really a boutique activity. It's really many companies envision that they'll build a product and then it'll be so horizontal, it'll be used by several millions of devices pretty fast. Unfortunately, it requires a lot of boutique activity to crack one market and replicate it to the other. But obviously, we are, again, on an exponential growth here. It's only getting better and faster. But I'm just telling why it took us so long to get here, nearly 40 years. But the next 10, 5, even a couple of years would look much different, much brighter, and developing much faster than the past 40 years.
We will take a short break. Stay with us, and we will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. Subscribe to our AFNet Silica newsletter or connect with us on LinkedIn. If you want to learn more about us, we have put information and links in this episode's show notes. You have mentioned talking about the future. I suppose that also AI and edge computing is shaping LoRaWAN as well. How are you adapting to that?
One of the reasons IoT will accelerate, putting aside anything I said, is AI, right? Because AI, it obviously has tremendous potential where it's still at the very beginning, right? And the AI is starting with digital data by using the data that's already available digitally. Now, the next challenge for AI would be to sense the physical world and command the physical world. That's where LoRaWAN comes into the picture. We are providing the foundation of massive IoT. We are the glue between the digital world and the physical world.
The data the sensors are collecting. Right?
Yeah, exactly. Yeah. Effectively, what we're building is the digital nervous system of the planet.
Yeah.
Sensing what's happening, turning it into digital data and transmitting that to the brain, AI and AI collections, and they do whatever they do. And if they need to command something on the physical world, again, the digital nervous system, LoRaWAN, carries it back to the physical world, like opening a valve or closing a door or ringing a bell, right? That's the big picture. Now, more specifically, there are LoRaWAN networks that leverages edge computing, meaning that LoRaWAN gateway and the LoRaWAN core network, which manages the network of multiple gateways, there are several products that combine them in a single box, physical unit, and also have the data processing. So all of the IoT is completely carried out on customer premise, data not leaving. And that happens for a couple of reasons. One, the site might be off the grid. There might not be any internet or a reliable internet. That's why all the decision and processing needs to take place at the site. Or two, for data privacy, certain organizations require data not to physically leave the site. So that's why we have edge computing. And that's where we also see the AI also marrying these edge computing to do full processing at the site. So that's where physically LoRaWAN and AI touches each other. And in fact, there's even a deeper integration. We see several use cases where the AI, machine learning, is running on the sensor itself. So we have a class of sensors that processes high amount of data like image processing or vibration processing. There are such sensors. The vibration sensors are used for predictive maintenance. The image processing is used for things like detecting people or counting people. But because the device doesn't want to transmit all this big data, it does the processing on the device, like counting how many people are in a retail store, or detecting if the vibration of a rotating equipment has deviated from its normal, which is an alarm situation, right? And then conveying that using LoRaWAN. Yeah, we have this type of sensors that has AI running on the sensor and communicating the outcome of the sensing using LoRaWAN. So we have all sorts of integration already. And like I said, both LoRaWAN and AI will accelerate by collaborating, feeding to each other. taking advantage of their roles with respect to the overall digital transformation.
Yeah, I like your nervous system analogy. That's really cool. You have mentioned public versus private
Mhm.
networks. How would you advise? How should enterprises decide? What?
Mm, Very good question. So we have multiple public networks all around the world. Some of them are fully nationwide, like in France, there's Orange providing nationwide network. In Switzerland, Swisscom. In Netherlands, KPN.
Mhm.
In Austria, Three or Hutchinson, three different names, same company.
Mhm.
So, and then we also have public network operators that has citywide networks already deployed and that can bring networks on demand. So when an enterprise needs LoRaWAN connectivity, they should first see if there is already a public network operating in their country providing the coverage they need. Sometimes physically the network is already there, and sometimes it is not there, but there is a public network they can contact and get an on-demand network built for them to start with, which gets shared by the others. So it is still a public network. So this is the first thing. And there's none of these options. Then obviously that enterprise would build its own LoRaWAN network.
Okay.
And unlike cellular, because with the cellular network, that's not an option because that enterprise wouldn't have a license. It would be too costly to build a 4G, 5G network. So that's a non-starter. But with LoRaWAN, there is this low-cost, high-accessible nature. So if there's no public network option, then they can build their own network.
Mhm.
If there's a public network, obviously they can make a judgment like, should I build my own network or should I use a public network? There's a cost, there's an availability, and it's very parametric, right? But then there's one other element. So if the devices of the enterprise is always on campus, obviously building a private network can serve that. But if
Mhm.
some of those devices are outside their campus, like going around the nation or other countries, obviously that enterprise wouldn't build a nationwide network. And that's where actually public and private collaboration comes into the picture.
Okay.
So an enterprise can build its own network, a private network, to connect its own devices, and also work with a public operator and set up a roaming agreement
Mhm.
such that the devices, when they leave their campus, they can roam into the public network and still stay connected. So with LoRaWAN, one can build public, private, and even community networks. The ability to support three distinct types of networks is very unique with LoRaWAN. No other
Okay.
technology can do that. But on top of that, we have the ability to integrate them together. So a device can roam from a community network to a private network to public network.
Mhm.
And that is definitely not seen anywhere else with any other technology either. And there are
Okay.
multiple examples of these. For
Mm.
example, in Romania, a company called ETA2U, they have their own private network for connecting water meters.
Mhm.
But they also have roaming with Helium network, a community network, such that if the data packets are received by Helium network, those are also forwarded to the ETA2U's core network. So that is an example of a private public roaming.
Mhm.
Similarly, in France, Veolia with 5 million water meters, they have their own private network, but some of those water meters are also roaming into the public Orange network.
Mhm.
So we have this collaborative technology, and also collaborative ecosystem.
And it's open source as well, right?
Well,
I think.
these are open standard, meaning that all of the work we do with the LoRa Alliance as we build the standard interoperability specifications are publicly available. Anyone can download them, read them, and implement them. On top
Mhm.
of that, we also provide an open source implementation of our specification. So the device makers and solution makers can use this open source implementation as well. So it's an open standard, open source implementation, and it's an open alliance. Anyone can join LoRa Alliance.
Mm.
This is a membership organization,
Mhm.
global nonprofit technology association. We have members from all around the world, all the way from universities to operators to system integrators, device makers. So I would highly encourage the audience to check it out, lora-alliance.org, see our membership, see the benefits. Whether you want to follow the technology closely or certify your devices, or you have the ambition to steer the technology to join this journey as we are revolutionizing the telecommunication industry, everyone is welcome to join us. Like you said earlier, we have more than 350 members, and the numbers are growing fast. It's a highly collaborative environment. All these companies are bonded together under the mission of making massive IoT reality. And we are on a great track right now. It's very exciting.
Yeah, it's really clear that this long-range, low-power networks are enabling complex mission-critical applications. That's really fantastic. Thank you, Alper, for coming on the show today and sharing your expertise. It has been truly insightful. Thank you very much for being here today.
Thank you very much, Ruth. Thank you for your questions and having me this chance to explain what we do in the industry.
So until next time, keep curious and keep innovating. This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.